Yes, that is correct. What else do you remember about the graphs of circles? Equations, graphing it. I heard some good discussion. Izzy, what did you tell me?
I said I vaguely remembered putting like 4 points down and then connecting those with curved lines to make a circle.
Did any other groups talk about that? Yeah, you put 4 points that were on the outside of the circle. You counted out to them. You counted out from sometimes the origin or wherever the center of the circle was. Okay, so you could find the center of your circle, and then you could count out in the 4 directions, up, down, left, right, whatever your radius was, and then you just drew a round shape. Right? Okay. Did anybody talk about that center point? I thought I heard a group talking about it. It is the middle of the circle. Yeah, that's where the center is. Okay, here's the equation. Write this down in your notes. X minus h quantity squared plus y minus k quantity squared equals r squared. And in that equation of the circle, HK is your center point, R is your radius. So for example, I'll just do one real quick. I'll make up x plus 5 quantity squared plus y minus 1 quantity squared equals, I'll do 16. Okay. What's the center of that circle? Careful. -5. +1. H and K in this case both look like opposites because they have the minus sign in front of them. So when you put in +1, it looks like y minus 1. And then what's your radius? 4. Why is the radius not 16? Because that's r squared, right? So to find the radius, you always square root the number on the outside. So we could do like what Izzy was describing. We could go put our center point. We'll count left 5 and up 1. Draw that little center point. And then from the center point, we could count out up 4, down 4, left 4, right 4, draw a round shape. That's graphing a circle. So that one will be pretty easy. Okay, what did you groups remember from equations of parabolas? Morgan?
Isn't it f of x equals a times, like in parentheses, x minus h squared and then plus?
Yeah, and if you're okay, I'll use y, but f of x is really y, but that is totally fine. Yeah. Okay, so that's the vertex form for a parabola. Did any groups talk about any other equations of parabolas? Standard form, which is? Excellent. My algebra 2 is coming through for me. I taught you all of these, didn't I? And there was another one. We didn't use it quite as often. It's called intercept form, but it's a times x minus p, x minus q.
I like that.
Yeah, I like that one too. It's basically, it's factored form, isn't it? Now that we've done all that polynomial work. Intercept form is the factored form of a quadratic. Okay, so you know the 2 intercepts. And some groups might have even talked about just like y equals x squared, right? Like that's the parent graph. So you might have just even shortened it to just that. Okay. Today we're going to be doing both parabolas and circles. Okay, and we're going to look at them like in terms of, we're going to look at the circles like we do in geometry because I don't like the way that you would do it with radicals is more for like if you were doing it in a graphing calculator, if you're trying to graph a circle. But I'm not, like, that's way harder on pen and paper. So if I were putting it into my graphing calculator, yes, I would use a radical like we're learning in this chapter. But I'm going to just review how to graph a circle from geometry, which is very easy. But we are going to graph some parabolas. And there's a big difference between the equations. How will we tell if it's a circle or a parabola? Okay, so circle or parabola equation. How do you know? If it's a circle, it has x squared and y squared, right? Look at the equation of a circle. Both the x and the y are being squared. If I FOIL out the x minus h, or y minus k, I'm going to get an x squared and a y squared. If it's a parabola, it only has x squared or y squared. Now, you've never seen a y squared parabola before, right? All the examples that you guys gave me, those are all x squared parabolas. That's because when we learned those parabolas in chapter 2 and 3, we were talking about quadratic functions. Functions for quadratics are used that open up and used that open down because they pass the vertical line test, so they are a function. What if you had a u that opened right? Or a u that opened left? Would it pass the vertical line test? Nope. So the y squared parabolas that we're going to graph today are going to be parabolas on their sides, which you've probably never seen before. Now, you can do it with radicals, that's why we're doing it now. And then there is another way to graph parabolas on their sides. It's part of conic sections, which would be in your next class with calculus. So let's do an example. If you want to write down x minus y squared equals 2, we'll name all the parts that it says in the directions as we graph. Okay. Well, when you get to conic sections, you might talk about how to graph this parabola without having to solve all the way for y. But do you agree that most of the time I ask you to graph functions, your equations look like y equals? Like y equals mx plus b, y equals 3x cubed plus 4x squared plus 2x plus 1, right? I'm always putting y equals in front. So we want to change this one to look like y equals. Now before we do that, can you tell if it's going to be a circle or a parabola? It's going to be a parabola because it only has y squared. So we know this one is a parabola, okay, because it has y squared only. Okay. And then we're going to solve for y. So I have x minus y squared equals 2. What do you want to do to get y all by itself? Many ways you could start this one.
You could either add y squared to the other side and subtract 2 to the other side.
Okay, let's do it. Add y squared. So I have x equals y squared plus 2. Subtract 2. Y squared equals x minus 2. And then square root. And remember, we talked about this already in chapter 3. If I square root to solve, what do I have to add to my answer? Plus or minus, right? Like, I don't know if this was a positive times a positive or a negative times a negative. So my answer is y equals, and this is different, plus or minus the square root of x minus 2. Well, yesterday you graphed square roots, but they would be positive or negative, not both. So this really means essentially you're graphing two equations. Y equals the square root of x minus 2 and y equals negative the square root of x minus 2. But do you see how that's going to give us a full sideways parabola? Because the negative one is just the reflected of the positive one. So we get the other arm of the parabola. Now when I normally ask you just to graph square roots, you'll have just the one little hill, right? But if you're graphing something that was y squared, when you solve, you'll have the plus or minus, so it'll be a full parabola. Let's talk transformations. What's that square root graph doing? Going right to. So I can move my starting point to 2, 0. I know 2 points on my parent graph, and there's no vertical stretch or shrink, 1, 1, 4, 2. So that's how I can move from my starting point. I'll go up 1, right 1, up 2, right 4. There's the positive square root of x minus 2. And then if I'm also graphing the negative, because there is a reflection from the starting point, I would go down 1, right 1. Down 2, right 4. And isn't that just a reflection of the arm above? Let me graph it right there. So this one is y equals the square root of x minus 2 on the top, and this is y equals negative square root of x minus 2. But both of them move, oops, I put the negative in the wrong spot, sorry about that. Both of them move right 2. This is right 2 and reflect. This one is just right 2. We okay with that? You got any questions for me? And again, the reason why we never studied that parabola before is it doesn't pass the vertical line test, so it's not considered a function. So all the things we did with quadratic functions, quadratic formula, finding vertices, all that stuff, that only works if it's a function. Okay. Okay. What's the vertex of that parabola? 2, 0. What direction does it open? Opens to the right. And I think I also asked you to do domain and range. Okay, so remember domain is x's where you see a graph. No graph, no graph, no graph, no graph. Finally a graph at x equals 2. And then a graph everywhere to the right of that. So all x's that are greater than or equal to 2. What about ranges? All real numbers. This arm's always going up. This arm's always going down. Oops, that's a y. Y equals all real numbers. Okay. Questions? Okay, I'm going to do one parabola that's going to be like a little bit different, all right? I want you to watch this. X plus y squared equals negative 4. We would do just like before. Like it has to be a parabola, right? Because it has y squared only. And then we're going to solve for y. So probably just subtract the x from both sides. Are you okay with that? Y squared equals negative x plus 4. And then square root both sides. So I'm going to square root both sides. When I square root, I have to add a plus or minus. Okay, I'm doing this one for a reason because I don't often make us look at this, but I'm going to do it for this problem. Now there's a negative underneath the radical, and it's right in front of x. So what does that negative inside the radical mean? It's a reflection in the y-axis. So think about a square root graph doesn't normally go to the right. If I reflect over the y-axis, now it's going to be opening over to the left. Okay. Okay. And then this is where we want to be really careful.
Could it also be like imaginary taking the square root of?
No, we won't plot any of the imaginary numbers. But if I put positive numbers in, like 5 doesn't work because then negative 5 plus 4 is imaginary. So over here at 5, there will be no graph. But can I put some numbers in like 0? 0 plus 4, it'll give me square root of 4, which is 2, so that'll work. So, like, I will have a point at 0, 2. Okay? But, like, what you want to know here is, like, that will be part of domain, but, like, there will be a graph over on the left side. There will not be a graph on the right side somewhere. Okay? Because it's being reflected in the y, so it's going that way. Okay. It looks like then if you call that a reflection in the y-axis, you might be tempted to say it moves in which direction? Just looking at it. Left 4, right? You would call that a left 4 movement. But remember, Isabella just asked me about, like, imaginary numbers, and I said, well, no, what if you can't put in 5? Okay, certainly 5 doesn't work over here, but could I put in 4? Negative 4 plus 4 is 0. Square root of 0 is 0. So, like, there is a point at 4, 0. So, like, this is why I want to do this one. In order for you to determine the left-right shift, you have to factor out the negative from the h. So I'm going to take out the negative from both terms. Since x was negative, it becomes a positive. Since the h looked like a plus 4, it's actually a negative 4. And this graph really moves right 4. Okay, anytime there's stuff underneath with x, in order for you really to say what this h is, you actually have to factor out what's in front of the x. And that's different. I don't make us look at that a lot, right? Because it is weird. But I'm letting us look at it now. This is a good opportunity to see where that happens. And doesn't that work out then? When we put 4 in, that's the square root of 0. So we're just going to shift our whole graph right 4. And that's that point. That's going to be our vertex. And then we said it's going to go to the left because it's reflected in the y-axis. So I can go left 1 up 1, left 1 down 1, left 4 up 2, down 4, or down 2, left 4. And there's my parabola. It opens left. Okay, so that is weird. We don't often look at that, but now is a good time for us to see that because it's just a negative and it's easy to factor out just a negative. My vertex is at 4, 0. And my domain is now x is less than or equal to 4, and my range is still all real numbers. Okay, because now I'm on the left side. If you reflect in the y-axis for a square root, it'll show up on the left. Does anybody have any questions about that? Okay, last thing really fast is a circle. It won't take us long. Okay, but I do want to at least show you domain and range. On this problem, how can I tell it's a circle? There's a square on both variables, right? It's got an x squared and a y squared. Now later on you'll learn that that doesn't mean it has to be a circle. There's something called an ellipse. It's like an oval. There are hyperbolas that have x squareds and y squareds in them. So there are other shapes, but for right now it's a circle. And instead of square rooting both sides and trying to graph the square root of 25 minus x squared, not very fun, okay? I'm just going to say make it look like the equation I gave you. So get the x squared and the y squared on the same side. So I just add x squared over. What's my center? I don't see any h's and k's. They must be zeros. And what's my radius? 5. The square root of 25, right? That's r squared in the equation. So I'll put my center as 0, 0, and I will count up 5, left 5, down 5, right 5. And I will say round, 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 round. That one was good. Don't often draw a good circle, but that one was pretty good. A little wonky, but not bad. Last thing on this one, domain and range. Circles are kind of fun for domain and range because like it only works on the x's from -5 to 5, right? Like it's all trapped inside. So we're going to write that -5 is less than or equal to x is less than or equal to 5. And then same thing for the y's. They got to be trapped in the circle. And so circles are my favorite ones to graph. They're so easy. I know. You just got to keep thinking round, 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 round.
Don't or what I did is I losing yourself.
Don't draw diagonals.
So now you have the crosshair. I just drew a curve line.
Round.
across.
Are you covering that up with you so I can't
So
see
just
it?
one big connected line.
Don't be ashamed of your circle. Be proud. You can do it.
House.
Okay, there are 2 review questions on the back. So you've got circles and parabolas on the front, 2 review, square root, cube roots on the back. Monday we'll do review for quiz, and Tuesday we'll quiz. We'll get all this information out before Thanksgiving break. How wonderful.
Yay.